Необходимость в диагностике автомобилей появилась тогда, когда появились первые автомобили. Для того, чтобы найти неисправность быстро и эффективно, необходимо создать специальный процесс, так называемую стратегию автодиагностики. Именно об этом мы поговорим с вами во время нашего вебинара 27 апреля. Но одним из пионеров в области стратегии автодиагностики была компания General Motors. Сегодня, незадолго до праздника Великой Победы, мы хотим показать вам очень интересный фильм, снятый компанией GM в 1942 году. В нем рассказывается о том, какова стратегия диагностики для грузовиков Chverolet G506. Этих машин было поставлено в Советский Союз по Ленд-лизу более 47 тысяч штук. Смотрите этот фильм и увидимся с вами на вебинаре.
More than they do today. To supply lines, mobility of our troops, and even victory itself depend on
engines in shape is a man-sized job, and it calls for plenty of care and attention. Whenever an engine feels like it's losing power, it should be inspected and repaired as soon as possible. A trained mechanic who might be given a job like this ought to be able to find the trouble at once. Checking for loss of power begins at the instrument panel. You should allow the engine to run until the operating temperature and the oil pressure show normal as specified in the maintenance manuals. There are three factors that affect the power output of an engine: compression, ignition, and carburation. Each one of these factors has a distinct effect on the inlet manifold vacuum and can be localized with a vacuum gauge. To check the vacuum of an engine, you simply connect this gauge to the intake manifold. Usually you can take off the windshield wiper hose and connect it there. Then you start the engine and watch the needle on the gauge. A motor that is just idling should show from 18 to 21 inches of vacuum. When the gauge pointer drops like this, it shows that one or more of the engine cylinders is receiving air from some source other than the intake manifold. That's generally caused by a valve that doesn't seat properly. It's like this. When a piston moves down on an intake stroke, the intake valve opens and allows air mixed with fuel to come into the cylinder through the intake manifold. If an exhaust valve is burned or stuck so that it doesn't seat properly, it allows the piston to draw air by it, and that reduces the amount of air drawn through the intake manifold, causing the needle on the vacuum gauge to drop. Whenever the vacuum gauge begins to react like this, you can be sure the engine is losing power. Now all you've got to do is make a compression test and find out which cylinder is causing the trouble. You use a compression gauge for this test. First, take the spark plugs out and look them over. They can help you find any cylinders that are on the blink. A cylinder that's pumping oil will make a plug look something like this. Then again, a plug like this usually means you've got low compression caused by leaking valves or bad rings. Once the plugs are out, you put the compression gauge in one of the holes and hold it down tightly. Then, with the hand throttle pulled out, You turn the engine over a couple of times with the starter and take a reading. At ordinary cranking speed, the pressure in the different holes should not vary by more than 10 pounds and should be close to the amount of pressure specified for the engine. When these pressures vary a great deal, that's usually a sign the valves are bad. When you find a cylinder with low compression, it usually means faulty valves, bad rings, or a blown head gasket. You can check further by pouring some motor oil in the cylinder. If the rings are bad, the oil will temporarily seal the compression and cause an increase in pressure when the retest is made. On the other hand, if the pressure doesn't go up, it means that the valves or head gasket are bad. Going on with the test, if you find the pressures of the two cylinders next to one another are equally low, that means there's a blown head gasket between them. The point to remember is that loss of compression comes from one or more of these three sources: worn rings and pistons, burned or stuck valves, or a blown head gasket. The next factor that affects engine power is ignition timing. When your engine compression is normal and the gauge shows a low, steady reading, that's a sign of late ignition timing. To check the ignition timing, you take a timing light and connect it to the high voltage lead and to the number 1 spark plug. Then you put the light in front of the opening in the flywheel housing. With the engine idling slowly, watch the opening. As the light flashes, the ball in the flywheel will appear to stand still. If you see that the ball doesn't line up with the pointer, then you've got to reset the ignition timing. But first, before you start to reset the ignition timing, you make this check. First, you vary the engine speed a bit and check the action of the vacuum advance unit. If the distributor doesn't move when you increase the speed, you'll know that the vacuum advance unit is defective, or at least that sufficient vacuum isn't reaching it. To find out whether or not sufficient vacuum is reaching the distributor, you connect the same old handy vacuum gauge to the vacuum line. First, of course, you disconnect the line from the distributor. And by the way, when you're doing that, you'd better use the proper wrench so you won't spoil the fitting. Now, with the gauge connected to the line, you increase the engine speed slowly and take a reading. It should equal the engine's present vacuum. And if it does, the distributor doesn't move, the vacuum unit is at fault. If you don't get any reading, the vacuum line is either clogged or leaking. The next step is to see that the mechanical advance is operating. You should be able to turn the rotor in the advance direction like this. Now, when you release the rotor, it should spring back to its original position. The third step is to make sure that the contact points are in good condition and spaced correctly. You can always find the correct specifications for breaker contact gap in the maintenance manual. Contact points have to be lined up right and free of pits before they can be properly spaced. Contacts that look like this can be adjusted to the right gap. But contacts that don't line up properly wear like this and make it impossible to get the right adjustment. When the contacts show too much wear, they should be replaced. If they're badly pitted, the condenser isn't working right, and both the points and the condenser should be replaced. Before you start to adjust the contacts, the rubbing block on the movable point must rest on the highest point of one of the cam lobes. Then you can check the width of the gap between the contacts with a feeler gauge. After taking these precautionary measures, you can reset the ignition timing. If the timing is very far out, your first step is to loosen the cap screw that holds the distributor retaining bracket. The bracket plate, as you can see, is calibrated in degrees to provide a guide for retarding or advancing the timing. To get the most out of an engine, the timing is set to compensate for the various grades of gasoline. Sometimes it'll be necessary to retard the timing to prevent fuel knocks. Now you place the bracket in its normal position with the center calibration mark lined up with the mark on the block and lock it tightly. You can make minor adjustments by just moving this bracket back and forth. Okay, the next step is to loosen the screw holding the distributor in the bracket. Then, holding the distributor body in its present position, you start the engine. Now with the engine idling, you move the distributor carefully in the direction necessary to bring the ball in the flywheel in line with the pointer. When the ball lines up with the pointer, the timing is set according to specifications. You hold the distributor body in this position until the locking screw is retightened. Once the timing is set right, the vacuum gauge should show a normal reading. The same procedure is used on trucks or cars that have the timing marks located on the edge of the fan pulley. And part of the procedure is to check the timing specifications before making any adjustments. If the vacuum gauge flutters like this and the engine doesn't idle smoothly, that's a sign of poor carburation. This condition can be caused by worn valve guides or valves that are adjusted too tight. So you should adjust them first before you make any further checks. After the valves are adjusted, if the vacuum gauge continues to react in the same way, you test the intake manifold for leaks. To do this, you stop the engine, close the throttle, and step on the starter. If the gauge reading doesn't rise rapidly to at least 15 inches, there's definitely a leak in the intake manifold. All connections around the intake manifold have got to be airtight to get proper carburation. Loose bolts at the intake manifold ports let air enter from the outside, and that makes the carburetor mixture too lean. After tightening these manifold bolts, you ought to make a recheck. If there are no leaks in the intake manifold, the needle will rise to normal rapidly when the engine is turned over. On the other hand, if the gauge reading doesn't rise to normal, you've probably got a cracked manifold or a burned heat riser. If it's a heat riser, you'll get exhaust gases in the intake manifold and ruin your mixture. After you're sure there are no air leaks in the intake manifold, you can start the motor and leave it idling. Then you adjust the carburetor idle mixture until the needle of the gauge remains steady in the normal range. When the needle reaches its highest point, the idle mixture is adjusted correctly. After you've got that, you speed up the engine and check the operating mixture. If the needle falls back and remains below normal, At a set throttle speed, you've got a lean mixture. To increase the supply of fuel, you pull the choke out very slowly and watch the gauge needle to see if it rises to normal. When it doesn't, you've got to make another check before you can blame the carburetor. You disconnect the fuel line at the carburetor and remove the line fitting, which you replace with a three-wave fitting. Then you connect the fuel line to this fitting. After you've done that, you connect the same gauge and start the engine. Your fuel pump pressure should be more than 2 1/2 pounds, but never higher than 3 1/2 pounds. If you find that the fuel pump pressure is all right, then you know the carburetor is at fault. If you keep these points in mind whenever you're troubleshooting an engine for lack of power, you'll do all right. First, you check the engine temperature and the oil pressure. Then you use the vacuum gauge to localize the trouble. The other thing to remember is this. There are 3 factors that cause loss of power. First, compression. Second, ignition. And third, carburation. When you've got these 3 factors under control, you'll get the maximum power out of any engine.